Okay, in this example, I want to take this truss, and I actually want to figure out the force in members HG and HB, which is this vertical member right here. So these two forces right here. Okay, so then rather than doing the joint analysis where I go joint by joint through all of these, what I can do is I can just use the method of sections and solve this in just a couple of equations. Okay, for this problem, these L's equal 2 meters. Okay, so what I'm going to do is I'm going to slice through right through here, right through HG and BC. Okay, and that's going to, again, oops, not that. I'm actually going to cut through going this way because I want to cut through HB. So my cut's going to go through HG, HB, and AB. Okay, so my free body diagram, when I cut through there, exposes HG, HB, and AB. Okay, now the book here, they have this as a compression. I always assume tension. That way if I get a negative answer, I know what that means. Of course, but what I'm looking for here is the force in HB and the force in HG. Okay, so there's my free body diagram. I've drawn the right side. Again, I can skip finding the reaction forces here because on the right side I've got a known force that I can use and no other unknowns. If I was to draw the left side after I made this cut, then I would have had to find these reactions at I and at A. Okay, but because I can draw the right side, that's what I've done. So I have this free body diagram. I'm looking for these two forces right here. I'm going to start with the sum of the force in the y direction because I have this 600 and this FHB. And that's all I have in the y direction. So I have FHB minus 600, meaning FHB equals 600 in tension. Again, this force right here balances this force right here in the y direction. Okay? And now I'm going to sum the moments to find HG. I'm going to sum the moments about point B. That way I get rid of FHB and FAB, and the only force I'm going to have in my moment equation is FHG. So I sum the moments about B, and I have 3 times FHG, right? This vertical force times this, this vertical distance times this horizontal force. That creates a positive moment, so I get 3 times FHG. Okay. Then I have this 600 Newton force. That's 4 meters over. That creates a negative moment, so I have 4 times 600 negative. The only unknown is FHG. I solve for that and set equal to 800. It's a positive answer, so that's also in tension. My assumption was correct. Okay, so make a cut through 3 members. Okay, realizing that the right side has no unknown support reactions, so I can just draw that right side through those 3 members, then just apply my equilibrium equations to figure out what those internal forces are that I made external through cutting.